Okay, Assalamualaikum. We are from Group 5. Our project is robotic arm, developing a robotic arm. And our members is I am Ahmad Faiz bin Effendi, and my other fourth member is Muhammad Adi Arham, Muhammad Muhammad Haris Iqbal, Muhammad Afiq Irfan, and Wan Ahmad Izham. Okay, as for introduction of robotic arm, a robotic arm is a mechanical device designed to mimic the movement and functionality of a human arm. It is typically composed of a series of connected segments, joints, and effectors that work together to perform various tasks. These robotic arms are widely used in industrials such as medical, researchers, and even household applications. Overall, these robotic arms have revolutionized many industries by providing increased efficiency, accuracy, and safety in various tasks. With ongoing advancement in robotics technology, it is expected that the capabilities and the applications of robotic arms will continue to expand and opening up a new possibilities for automation and human machine collaboration. So by developing a cost effective and adaptive robotic arm, this project contributes to ongoing process in robotics and offer a solution for various industrial settings. Thank you.
My name is Wan Ahmad Zamil Hassan, metric number 1927703. I will continue this presentation by stating three main objectives of this project. The first objective is to conduct a true analysis of the expected loads and forces. Second one is to perform stress analysis using FEM method to determine how the applied loads affect the different components of robotic arm. The third objective is to identify potential failure modes that can occur in the robot arm. For problem statement for this project focus on designing and analyzing a robust robot arm to withstand load and stress requirements while considering potential failures. Second one, using finite element method to identify critical areas, improve structural integrity, and optimize design for enhanced performance and reliability.
I am Muhammad Adi Arham bin Muhammad Azam. My metric number 1921233. So I will continue with the conceptual design. So the conceptual design is the stage in creating the a robotic arm for manufacturing machine parts. So at this stage, it involves defining the overall structure, functionality, and the key component of the arm. So it serves as the starting point for the stage of detail design and the construction that follow. So to design the, to achieve the design goals and the specification, so we need to consider the factor such as the precision, strength, speed, and the compatibility with existing machinery. So rather than that, we need to determine the degree of freedom, which is we know as the DOF of the robotic arm that required. So DOF also refer to the number of independent motion or axis that the arm is capable, and then a larger DOF now a larger DOF number typically enables better flexibility and maneuverability. So we continue with the FEA. We conduct the FEA for bolt, and then we assume that the force is 1 kilonewton, and then we calculate to find the dm, dr, and the length. For dm, we got the value is 27.5 mm, the dr is 25 mm, and the length is 10 mm. Next, we calculate for the torque. We calculate the torque that required to turn the screw against the load. and we get 8.736 Newton meter. And then we calculate for the lowering torque for the load, which is 3.911 Newton meter. And then we calculate for the overall efficiency in raising the load. We got 0.5395. Next, we calculate for the stress. Uh, we got for the body shear stress is 2.847 megapascal. And then the axial normal stress is 2.037 megapascal. Uh, and then 5.806 megapascal for the trade root bending stress. And then we got for the von Mises stress is 5.102 megapascal. And then the remaining principal stress is we got for the first is 4.042 and negative 2.005. After that, lastly, we calculate for the maximum shear stress is 3.9055 megapascal.
So next is the conceptual design. So here are the components that we have built or created in the SolidWorks. So then we transfer the model or the components into the auto investor to calculate the maximum stress for each components. So as we can see here, there are three components, which is the connecting gear, the link, and the gripper. So after we calculate the maximum stress for each component, we can get that the connecting gear is 177.9 megapascal. For the link, it is 80.61 megapascal, and for the gripper, it is 0.95904 megapascal. So this is just the analytical calculation for the conceptual design. Next, after the conceptual design is complete, we continue with the embodiment design. Embodiment design is a crucial stage in the product design process, aiming to create a best design layout for detailed design. This is mentioned by Becker in 2009 in its own website. And then after that, the product is developed based on the selected concept, focusing on the technical and economic criteria such as function, durability, production, assembly, operation, and cost. So we for that we choose the design 5 as our project design for the robotic arm, and this is our proposed design. And below that is our final design, which consists of shaft, gear, arm, link, and bearing, and gripper, and others. So that's all for the embodiment design.
Hi, Assalamualaikum. My name is Afiq, matric card number 2013783, and I will be presenting the discussion and also the conclusion part. In general, robotic advancement have revolutionized the industries and also enabling automation and precision. This is a very crucial part in the industries because precision is what we aim for us to get the best quality of the product. I will do this discussion part into four categories, which is first application, contribution, stress analysis, and also control. Okay, so for the first part, which is the application, we can see that robotic arm is widely used in several field in the in engineering field, which is manufacturing. It is used in assembly line automation, in healthcare, surgical assistance, logistics, package handling, research, laboratory experiments. So we can see that robotics arm is widely used and is very indeed needed in the industries to gain higher precision and also to increase productivity. Moving on into the contribution part, for this project, we contributed in improving the robotic arm design and also investigate the materials and also manufacturing techniques of this robotics arm. Besides optimizing and controlling the algorithm, we also ensure the modularity for the future upgrades and also from what we have designed in the robotic arms, we are aiming for better functionality of the robotic arms. So in this project, we have done stress analysis for each part of the robotic arms. So utilize the finite element analysis, which is FEA for stress analysis, and from this analysis, we can identify areas of high stress concentration, and from this, we know that what's the maximum weightage that the robotic arm can lift and also how many stress it can undergo before it reach its failure point. So for the last part in this discussion, which is the control part. The design of the robotics arm, we ensure the degree of freedom for the robotic arm is to the maximum level as possible so it can freely move uh, in 3D movement. So we select and integrate joint, actuators, and sensors so that it will function to move around objects and also can function as the users wanted it to be. And the last one, we implement intelligence control system for precise task execution. Just like what I said just now, in order to get the best out of the robotic arms, it should be function as what as the users have key in the data. As for the conclusion, our goals include stress analysis, design optimization, exploring applications, and also advancing robotics. By achieving this objective, we create an affordable, flexible robotic arm that revolutionizes the industries. As what we have discussed just now, robotics arm is what the futures need to to improve the quality and also the productivity of certain um, field in the manufacturing area especially. So we believe that from this project, um, robotics arm can improve its function and also its manufacturing material so that it can withstand higher rate of uh, load and also it can function well in the future. Technology and collaboration pave the way for harmonious human-machine coexistence so that we can benefit from each other and improve to get the best outcome as possible. So I think that's all from me. Moving on to the next presenter. Thank you and Assalamualaikum.
So next, we continue on the recommendations. So here are some of the recommendations that can improve our design of robotic arms. So for the first one is generate 2D drawings, exploded views, and BOM, which is bill of materials, to communicate the design intent effectively. Second is include the additional features such as cable management, mounting brackets, or sensor integration in order to improve the functionality and simplify integration with other systems. And the last one is use precise dimensions for our components, so based on the design requirements to achieve the desired range of motion, strength, and stability.